Okay, class, this is Chapter 9, which is titled Reconstitution of Powders or Crystals into Liquid Medication. This is Lecture 4, and I am going to pick back up with the practice problems A, started with number 3. But again, as usual, you should have already read your Chapter 9 within your book. You should have already reviewed the Chapter 9 PowerPoint and have read the Chapter 9 lecture notes provided to you within Blackboard. So moving on, we are on page 307 and we're looking at number 3. Number 3, it provides you a label. It provides you a label of Tazef and it says 1 gram. And below that label, it says reconstitution, single dose vials. And it has a table. And within that table, it tells you the vial size, the diluent to be added, the approximate available volume, and the approximate average concentration. So if we were doing a IM or IV bolus, direct bolus, as it says, a bolus is a medication a patient's going to receive to get them to their therapeutic level. So they can receive a bolus of 800 milligrams in one sitting. That's basically what a bolus is. So with that bolus, that intramuscular IV bolus is saying for a 1 gram, they are to add 3 milliliters, which gives them an approximate volume of 3.6 milliliters with a concentration of 280 milligram per milliliter. Before I move on, let's go ahead and identify the components of this label that we have so far wrote down. So for this Tazef 1 gram, this 1 gram identifies your total dosage, which is basically, again, the weight of the powder. Okay? Now, the intramuscular IV bolus is telling you that if you're using the 1 gram, you are to add 3 milliliters. All right? Well, that's your diluent volume. The approximate volume, once you add that 3 milliliters, is the final volume, and that 280 milligrams per milliliter is considered your what? Your dosage strength. Well, let's keep reading on the label. It tells you that for an intravenous infusion, so I'm going to put an infusion. It says that if it's a 1 gram, they're to add 10 milliliters. That gives them a 10.6 milliliter volume, which gives them a 95 milligram per milliliter dosage strength. If it was 2 grams, they will add 10 milliliters of volume, which gives them 11.2 milliliters of approximate final volume, which gives them a concentration of 180 milligram per milliliter. So again, let's identify these components. The 1 gram and the 2 grams identifies your what? Your total dosage. The 10 milliliters for both identifies the diluent volume that should be added. The 10.6 and the 11.2 milliliters is the final volume once you add the diluent volume. And that 95 per milliliter and 180 milligrams per milliliter is the dosage strength. So I ask you, is this a single strength medication or multi-strength medication? So once you add your diluent volume, do you have multiple diluent volumes and multiple dosage strengths available? That is how you answer that question. So yes, I do have multiple diluent volumes, which is a 3 milliliter and 10 milliliter. And I also have multiple dosage strength. One is 280 milligrams, one is 95 milligrams, one is 180 milligrams per milliliter. So this medication is considered a multi-concentration or multi-strength medication. All right. Well, let's answer the questions. So the very first question, it says, what is the powder volume for IM usage? So again, let's look back at our label. For intramuscular usage, it says that if you add 3 milliliters, you get approximate volume of 3.6 milliliters with a concentration of 280 milligrams per milliliter. All right. So in order to solve your powdered volume, remember your formula is PV equals FV minus DV. All right. So my final volume for intramuscular is 3.6 milliliters. And the diluent volume that was added for that intramuscular injection was 3.0 milliliters. So if you subtract the two, the powder volume total is 0.6 milliliters. All right. Well, let's look at B. B says, what is the powder volume for intravenous infusion at 1 gram? What is the powder volume for intravenous infusion at 1 gram? Remember, your formula is still the same. PV equals FV minus DV. All right. Well, for my intravenous infusion at 1 gram, it says that my final volume is what? 10.6 milliliters. And my diluent volume that was added is 10 milliliters. If you subtract the two together, PV equals 0.6 milliliters. All right. I'm going to have to erase A and B so I can answer C for you guys, or work on C for you guys. So C says, what is the powder volume for intravenous infusion at 2 grams dosage? So remember, your formula is still the same. PV equals FV minus DV. All right. So my final volume of the intravenous infusion at 2 grams, you guys read on that label, is 11.2 milliliters. The diluent volume that was added was 10 milliliters. If you subtract the two together, your answer should be 1.2 milliliters of powdered volume. Well, that does make sense. All right, so a couple of things that I want you guys to remember is that your powdered volume never changes. All right. In this case, you may say, well, Miss K, my powder volume did change. But if you look at the label at the very top, it tells you that it's 1 gram. So that means you need 2 vials to equal to 2 grams. So if I was to use the powder volume for intramuscular usage and intravenous infusion at 1 gram, the powder volume, as you can see, the answer is 0.6 milliliters. What also does not change is your total dosage, your total dosage never changes. It is what it is. The weight of the powder remains the same regardless of how much water you add to the container or how much diluent volume you add to the container. Your total dosage always remains the same. It never changes. Your powder volume never changes. But what does change is that your diluent volume will change. And when it does change, it will either increase or decrease your dosage strength. Remember that. So, whenever you have a total dosage, and with that total dosage, if you're adding a diluent to it, you are going to change the dosage strength. All right. So your total dosage is not in detail the dosage strength or how much medication the patient should be receiving in one sitting. All right. So when you add to your total dosage, you are creating a dosage strength. That diluent volume goes from, it can go from 10 milliliters to 9 milliliters to 8 milliliters. Whatever it goes to, it will change your total dosage. If you look at that label on page 307, that 1 gram, if I add 3 milliliters of diluent volume, my final volume changes to what? 3.6 milliliters, which then gives me a concentration of 280 milligrams per milliliter. But if I add 10 milliliters instead of 3 milliliters, it changes my final volume to 10.6 milliliters, which then changes my dosage strength to 95 milligrams per milliliter. So the more diluent you add to a container, the lower the concentration is, or the lower the dosage strength would be. The less diluent you add to your medication, the higher the dosage strength will be. All right. So we're going to continue on in lecture 5 for the next couple of practice problems. Again, if you have any questions, please feel free to send me an email and I will respond to you as quickly as I can.